Okay, so we have a few problems for test review for warm-up. So we're going to start on page 61. Pause the video here, you try the problems, work with each other, and then we will unpause and watch the solutions. Okay, so for number 1, in Mrs. Weiss's candy jar, she has 7 red M&Ms, 8 green, 5 brown, and 10 yellow. Okay, that's a lot of M&Ms. So if a student chooses 2 M&Ms without replacement, what's the probability they get different colors? Well, there's a really, really long way to do this problem and then a much more efficient way. So the long way would have to look at red then green, green then red, red then brown, brown then red, and all the different possibilities of the colors. However, instead of thinking of all the different ways to get different colors, I'm going to find the opposite or the complement of the probability of finding the same color. Because if I find the same color, that's red then red, green then green, brown. It's much, much less math to do, which this is going to give me the probability of different colors as an answer. Okay, so the probability of same colors is going to be the probability of red and then a red. So let's see. We have 7 plus 8 plus 5 plus 10. So we have 30 M&Ms. So that's going to be 7 out of 30 times 6 out of 29. And we're going to calculate that. Then the probability of a green and then a green, that's a P, is 8 out of 30 and 7 out of 29. And then the probability of brown and brown is 5 out of 30 times 4 out of 29. And then the probability of yellow then yellow is 10 out of 30 and 9 out of 29. Okay, so let's calculate these. 7 out of 30 times 6 out of 29. 0.0483. 8 out of 30 times 7 out of 29. 0.644. 5 out of 30 times 4 out of 29. 0.220. Let's go 99. More decimal places the better because we're not at our final answer yet. So I don't want to round this up to 0.23, only because I'm still in the process. So while I'm doing the work, I want to err on the side of more decimals than not. Okay, so if we add all of those up, that is the probability of finding the same color. So let's see, 0.0483, 0.0483, 23914. So if I take 1 minus that, so 1 minus 0.23914, the probability of getting different colors is 0.76086, or as a percent, 76.086%. Okay, number 1's done. Number 2, complete the Venn diagram below. 30% of students are going to prom, 50% of students are going to baseball, and 45% are going to neither. Okay, well to start, I can put 45% and the neither. So 30% go to prom means this whole circle, let me get a color, the whole prom circle has to add up to 30%. And the whole baseball circle has to add up to 50%. So if I do 30% plus 50% plus 45%, that's more than 100%. So that extra of 25% is the overlap of prom and baseball. So that leaves, so if we take away, that leaves only 5% that went to prom without baseball, and 25% that went to baseball without prom. Okay, now we can answer everything else. What is the probability a student is going to prom given that they are going to the baseball game? Okay, so prom given that they are going to baseball. So that is the probability of prom and baseball over the probability of baseball. So the prom and baseball is 25%. Overall baseball is 50%. So 50% chance of prom given baseball. What's the probability of students going to baseball or prom? It's the probability of baseball or prom. So that's going to be 5% plus 25% plus 25%. If you do the totals, you have to take away the doubly counted intersection. I guess I really didn't need a calculator to do that. It's 0.55, so 55% for either one. Is attending prom and baseball independent? Okay. This word, you have to show a solo, the event by itself compared to a conditional. Your other choice is if you do baseball, you would compare that to baseball given prom. Either pair is right, but you have to have a conditional to compare it to the event by itself. Well, I already have this calculated, so I'm going to use this one. And the probability of prom is 30%. They're not equal, so not independent. If you really want to do it this way, baseball is 50%. Baseball given prom is the intersection over prom. It's 83%. Again, not equal, so not independent. Okay, now page 63 is one more warm-up practice problem. The probability a student takes Honors Algebra 2 is 40%. Probability a student takes AP Psych is 20. Probability a student takes neither is 48. Okay, so let's see what my extra amount over 100 is. 8%. So 0.08 goes here. And we get 32% in only Algebra 2 and 12% in only AP Psych. Are Algebra 2 and Psych independent? Okay, so I'm going to compare the probability of Algebra 2 with the probability of Algebra 2 given Psych. Oh no, I'm going to do it both ways. Just to show, either pair is fine. You could pick either one, you don't have to do both. So the probability of taking Honors Algebra 2 is 40%. The probability of Algebra 2 given Psych is the intersection of the two over total Psych. And let's see. That's 40%. They're equal, so that is independent. That's cool. Let's see it the other way. The probability of Psych is 20%. Probability of Psych given Algebra 2 is their intersection over all Algebra 2. They're equal, still independent. If you do it both ways and they don't match, then something's definitely wrong. But one way or the other is okay on your test.